Hi dears, welcome to today's session on units, dimensions and measurements. This topic is fundamental topic in physics which gives more marks in examinations like UPSC NDA, Navy, Air Force, central examinations like CUT, IIT JEE, state examinations like MSET, EPSET. So that this chapter is very important topic in understanding physics very well. So without wasting time, shall we move into the concept? Yes. What is measurement? Measurement is nothing but a comparable one which we are going to be comparing with a standard material. So here how measurements are used in our daily life. You can look at the figure. Our daily life dealing with the measurements like measuring the milk, sorry, to analyze the milk or to measuring the fruits, we need measurements. For example, you can see figure here. This is a measurement of mass. This is a measurement of milk in value. So not only these two, our daily life is dealing with the measurements. Measurements are very essential in our life. What is the need of the measurement in physics? As you know very well, physics deals with nature. To understand the phenomena in physics, we need measurements. To understand the phenomena of physics, we need measurements. Experiments require measurements. So we measure several physical quantities such as length, mass, time, temperature, pressure. So experiments require measurements and that measurements measured by using several physical properties like length, mass, time. Experimental verification of laws and theories also need measurement of physical properties. So, in physics, the experimental verification of laws, theories need measurements for their accuracy description. So, like that, we need measurements in physics. What are physical quantity? So, physical quantity is what? A physical property which can be measured, and described by a number. It is going to be measured and described by a number, and that is called physical quantity. For example, mass, length, area, temperature. So these are few examples of physical quantity. I think you are understanding. So mass of a person, that is 65 kg. Length of a table 3 meters. Area of hall 100 meters square. Temperature of room 300 Kelvin. Physical quantities classified into two types. One is fundamental quantity, another one is derived quantity. Fundamental and derived. Let's see what is fundamental quantity. A physical quantity which do not depend on any physical quantities, any other physical quantity. It expresses itself. Not depend on other physical quantities such as mass, length, time, temperature. They do not depend on other physical quantities. Second one, the examples of the fundamental quantities. We have 7 base fundamental quantities: length, mass, time, temperature, current, amount of substance, luminous intensity. Length dimension, the representation dimension is L, mass M, time T, temperature that is Kelvin, current ampere, amount of substance mole mol, luminous intensity candela. So these are the dimensions. This is the dimension of the luminous intensity. This is the unit of the CD name. CD means candela. So length, mass, time, temperature, current, amount of substance, luminous intensity, these are 7 fundamental quantities. Coming to derived. So here physical quantity which depend on one or more fundamental quantities. One or more fundamental quantity. That means they depends on fundamental quantity. For example, we can take speed. Speed equal to distance by time. See, time is a fundamental quantity. Force, mass into acceleration. Mass is fundamental quantity, which means amount container of an object. Mass, see, force is ma, where m is nothing but mass. Mass is nothing but what? Fundamental quantity. So that derived quantity means which depends on one or more fundamental quantities, that is called derived quantity. Coming to others, there are two more supplementary units. Supplementary angles we have, supplementary quantities we have. One is called plane angle, another one is called solid angle. Plane angle, solid angle. They have units. These units, the plane angle unit is called radian. Solid angle unit is called steradian. Plane angle unit is what? Plane angle is supplementary quantity, and the supplementary quantity will have a unit, and that is called radian. Solid angle is supplementary quantity. This supplementary quantity will have a unit that is called steradian. So solid angle unit is steradian, plane angle is radial. So these two are known as supplementary units. So some more measuring lengths in practical. If you go to the atomic structures, microorganisms, crystal structures, there we are using a different terms to represent their length or their size. For example, micron. Bacteria, virus, small organisms can be measured in micron form. So like here, we will consider 1 micron. It is a 1 by 6. That means in meter 10th part. That means 10 to the power of minus 6 is known as 1 micron. Coming to 1 nanometer. In meter the 9th form. That means 1 nanometer equal 10 to the power of minus 9 meter. Then 1 angstrom. Angstrom is nothing but in meter 10th part, which is nothing but 10 to the power of minus 10 meters. Nucleus, size of the nucleus, that is about 10 to the power of minus 15 meters, which we call Fermi. 1 Fermi equal to 10 to the power of minus 15 meters. 1 angstrom 10 to the power of minus 10 meters. So here a few examples. Based on this topic, we have few questions which are given based on the MCQs. So there may be numbering is a zigzag. Please don't consider that numbering. Just you focus on questions. First question is about what is the dimension formula of the Planck constant. What is dimension formula? First of all, dimension formula is nothing but the physical quantity express in terms of what is that? In terms of power of fundamental quantity. That is what? For example, mass, length, time. Any physical quantity, if we express in terms of power of fundamental quantity, and that is known as dimension and that is represented in square bracket, then it is called dimension formula. For example, force. Force is equal to mass into acceleration. Mass is m, acceleration is what? Acceleration, rate change of velocity, which is nothing but v by t. So v by t. Mass m as it is, v is nothing but what is that? Meter per second. Otherwise, I will go with a small one. Length we express with the L, mass expressed with the m. Similar way, distance expressed with L, speed expressed with the distance by time. So distance is nothing but L by T. Now you will get L T minus 1. This is known as dimensional formula. See, dimensional formula is nothing but expressing physical quantity in terms of power of fundamental quantities. That is known as dimensional formula. So in the question 1, we have dimensional formula for the Planck constant. Without wasting time, just look here. So E equal to h nu. H we want, which is nothing but Planck constant, h equal to E by nu. What is E? E is nothing but m L square T minus 2. This is the dimensional formula for the energy. Frequency nu equal to T power minus 1. After replacing the given values, then we will get m L square T minus 1. This is the dimensional formula for the Planck constant. These are not. So this is the correct representation for dimensional formula. So don't consider question number. Another question, these are very essential for the NDA, CET, IIT, JEE, other examination. I cover this by considering all examination, not single examination. So here the question, the percentage error in measuring the mass of a cube is 1% and the length error is 2%. Then what is the maximum percentage in error in density concept, density calculation? So here, look here. First of all, what is the error in mass? Error in mass, we expect delta m by m. This is called error in measurement of mass, that is 1%. Similarly, error in side length, that is 2%, plus or minus 1%, plus or minus 2%. So now our question is density. Density is what? Mass by value. Mass by value. So here mass is what? Error value. What is error value? So that is delta m by m by delta v by v. So here delta m by m is what? 1%. That is 1% by delta v by v is how much? That is about 2%. You should not divide. Even though it is minus or division or anything, that must be added. So here, so we have L cube, that is about 3. So that we will get 1% plus 3 into 2%, which is about 1 plus 6, which is nothing but 7%. I will explain once again. Don't worry, I will explain once again. The question is asking about the density calculation, percentage error in density. Generally density equal to, here we have density equal to m by v. Then we have error in mass and volume. So error in mass is delta m by m. Error in volume, before volume we have to consider length L cube, no? So that is delta L by L, which is about 3%. Our formula is what? You can see here, power of m into error in m. Power of m is how much? 1. and error in m is what? 1 percentage. Power of error in length, what is that? Delta L by L. Length is how much power? That is 3 percentage. So 1 plus 3 into 2, which is about 7 percentage. Okay, don't be confused, nothing is critical, it's simple one only. Coming to next, sorry, this is third one. Don't go for the don't focus on question number. So here question number, next question. So if the main scale reading is 10 millimeter and Verniers coincide division is 5, what the least count of the Vernier scale is 0.1 millimeter, what is the final reading? So here the formula is MSR plus VSR into LC. Main scale reading, Vernier scale division into least count. Replace here MSR. Main scale reading is how much? 10 millimeter. Vernier coincide is how much? 5. So replace least count is what? 0.1 millimeter. After putting the values, then you will get 10.5 millimeter. Like that we will measure. So this is called main scale and this is called Vernier scale. It is Vernier scale is Vernier's calipers is used to measure the diameter, internal diameter, external diameter, and depth of a object or device can be measured by using of Vernier calipers. Then coming to next one, screw gauge, Vernier calipers, spirometer, these are called as the sensitive devices which are used to measure the least count. What is least count? Smallest length or smallest measurement measured by using of sensitive devices such as screw gauge, Vernier calipers, spirometer. Okay, if a screw gauge has pitch how much? 1 millimeter, 100 divisions of circular scale, what is the least count? Here the question is asking about least count. So least count formula is what? Pitch by number of circular scale divisions. How many circular scale divisions we have? 100 circular scale divisions. So 100, 1 pitch is how much? How much pitch? 1 millimeter. Pitch is nothing but distance traveled by the screw gauge. See, this is nothing but pitch. How much distance it is travel? See, this is about pitch by number of circular scale divisions. So 1 millimeter by 100, which we will get 0.01 millimeter. So this is about screw gauge least count. Vernier calipers is 0.1 millimeter. Here it is 0.01 millimeter. Next one, a measurement that is very consistent but far from true value. What is true value? True value is nothing but exact value, and which is nothing but standard value. So here we have given certain values. So I am directly going to the answer. True value is far away when, see, this is high precision, high accurate. Precision means high precision. So the closest value. Precision means closest values. Repeated closest. Accuracy means exactly. For example, if you conduct a test in the for 100 marks, we conducted an examination. If you got 99.99, then this we call as accuracy. In the same test, some will get 98.7, 98.6, 98.5, 98.1, 92.3. See, 98.7, 98.6, 98.5, they are close. Repeat, these are very close to each other, very closeness value. So this we call precision. Okay, here coming to this question, measurement that is very consistent but far from true value, and that is simple one, low accuracy and high precision. Accuracy is low and precision is high. See, accuracy means true value is 100, accuracy value is you taken as 23 or 26. Does it valid for good measurement, consistent measurement? No, accuracy it is low. It must be. You want good true value near to the true value, that must be high accuracy, high precision. But here they are asking negative one, so that low accuracy, high precision. Coming to next one, what is the dimension of surface tension? See, surface tension formula F by L. So F, as you know very well, mlt minus 2 by L. So that is mt minus 2. This is about surface tension. Surface tension, force per length. Surface tension is force per unit length. The dimension is about force per length, which we call mt power minus 2. Coming to which type of error is categorized as systematic error. See, we have personal errors, zero errors, random errors, and systematic errors. Like that, we have systematic errors, random errors, personal errors we have. So here our question is systematic error. Systematic error, we have given option. Personal error is not systematic error. See, sorry. So here systematic error is what? So zero errors are known as systematic errors. Systematic errors are have a known and identifiable cause. They have known and identifiable cause, which express as systematic errors. They are constant over underestimation. They see zero errors are known as systematic errors. Personal error is about instrument error. They have, but we are setting to the zero. And random error is unpredictable. And instrumental error is come to the zero error, but we have to set it. But your final answer, that is about the systematic error, is simple one. Zero error is known as systematic error. Which of the following pair? Next one. Which of the following pairs of physical quantity has the same dimensions? See, dimensions are work equal to force is nothing but mlt minus 2, power p equal to w by t, which is nothing but work dimensions are what? Work dimensions m l square t minus 2. So they are not equal. Momentum p equal to mv, energy E equal to mc square. So this is meter per second, this is meter square per second square. So these two are not. Surface tension, viscosity. Surface tension is F by L. Viscosity, it is different dimension. So our answer is about work and torque, where work is Fd, torque tau equal to R cross F, perpendicular distance, and force and displacement, that is about work. So they have same dimension. Dimension formula of work is ml square t minus 2, and dimension formula of the torque is ml square t minus 2. So these two are same pair dimensions. Which is next one? Which of the following quantity has a dimensionless? See, dimensionless is, this is the angular velocity. Sorry, not dimensionless. That is literally they are asking 1 by t. 1 by t minus 1 or 1 by t or t minus 1 dimension they are asking. See, this is about the angular velocity. Angular velocity is what? Angle by time. And velocity gradient is what? Velocity by distance. So here you can see here angular velocity is angle 1 by t, that is t minus 1, and velocity gradient, that is what? dv by dx. dv by dx, meter per second by second. Again you will get, sorry, meter dv by dx, this is also meter, so it is also minus. So that the answers angular velocity and velocity gradient. Angular velocity and velocity gradient both are all having the unit of m naught l naught t power minus 1. Recheck once again, don't worry. Next one, radian and steradian are supplementary units for what? Radian and steradian are the supplementary units for the radian, for the plane angle. So but luminous index is not. This is candela. Here mole, amount of substance means. So It is they are zigzagging. So here radian for the plane angle, steradian for the solid angle. So your answer is D. Coming to the next one. How many nanometers are there in 1 kilometer? 1 kilometer. 1 kilometer. 1 kilometer means what? 10 to the power of 3 meters. Is it right? So now 1 meter. 1 meter means what? 1 meter. Our question is nanometer. So that means in meter relation to the meter to nanometer 10 to the power of minus 9. So that is 10 to the power of minus, sorry, that is about 10 to the power of 3. So 1 nanometer equal to 10 to the power of minus 9 meters. So 1 meter equal to 10 to the power of 9 nano. So that 10 to the power of 12 nanometers. You can see the explanation also. 1 kilometer measures longer distance. Prefix kilo is 10 to the power of 3 base. Unit 1 kilometer equal 10 to the power of 3 meters. 1 nanometer measures the nano or molecular distance. Prefix nano is 10 to the power of minus 9 base. Definition: 1 nanometer equal 10 to the power of minus 9 meters. So after equating, we will get 10 to the power of 3, 10 to the power of 9, which is about the 10 to the power of 12. Your answer is 1 kilometer is equal to 10 to the power of 9 nanometers. So 10 to the power of 12 nanometers. Coming to the next one. How many femtoseconds are there in 1 microsecond? So here, just go for the description, explanation. 1 microsecond measures the standard computer timing. Prefix micro is 10 to the power of minus 6. 1 microsecond 10 to the power of minus 6. Whereas femtosecond is measured 1 nano laser nanomolecular distance. Femto is 10 to the power of minus 15 base. So here 1 femtosecond is equal to 10 to the power of minus 15 seconds. After replacing, you will get 10 to the power of 6, 10 to the power of 12. Then you will get 10 to the power of 10 to the power of 10 to the power of minus 6 into 10 to the power of minus 15. We have 1 microsecond. So how many femtoseconds are in 1 microsecond? So here 1 microsecond 10 to the power of minus 6 microseconds. So here 1 second, so 10 to the power of minus 6, and femtosecond is 10 to the power of minus 15 will be changed. We are taking 1 femtosecond is 10 to the power of minus 15, but 1 second we are 10 to the power of minus 6 seconds. So once this second equal 10 to the power of minus 6 and 10 to the power of 15. After replacing, you will get 10 to the power of 9. 10 to the power of 9. Okay, this is option C is the right answer. Okay, check the answer. So that is about 10 to the power of 9. You can calculate again. Okay, next for the number 0, 0, 1, 2, 9, 0, how many significant figures? This is non-significant. Only 1290 is the significant figure number. So the significant figures are for rule 1. All non-zero digits are significant. This is significant. Capital all zeros between the non-zeros will be significant. Zeros left trailing are non-significant. These are the non-significant. Zeros after the decimal, they are the significant. So now your answer, this non-significant, significant. So your answer is 4. So this type of questions will be coming in examinations. These are not, you are thinking these are very easy, but while we are doing the examination point of view, we will get some confusion. So before that one, please shut out your doubts and get the full clarity on the concept. Okay, next one, what is the significant figure? 12.437 rounded to 3 digits, a 3 figure. So here 12.43, and that is after 4 3 you have 3 7. So that is, we are asking for the only for the 3, so that is simple one. 12, the question is about rounded to 3 significant figures, that is about 12.123, so that is about 12.4. So that is a rounding numbers. So next, what is the gravitational dimension? Gravitational constant, as you know very well, F equal g m1 m2 by r square. We want this value, g equal to f r square by m1 m2. See, f is nothing but ml t minus 2, r is nothing but length, m is here. So g equal to, after placing the these values, then you will get, in the simplification, m minus 1, you will get m minus 1 l power 3 t minus 2, and this is about the gravitational constant dimension. Coming to next one, which of the following quantity has the same dimension formula for pressure? See, pressure is just like stress. Pressure P equal to F by A, where F ml T minus 2, area L square. After placing the values ml minus 1, T minus 2, the SI into the pressure is Pascal. And similarly, pressure, we have stress. Stress is nothing but F by A, and which also we can consider Pascal or Newton per meter square, but most precisely we are using Pascal. So here, this is the force mlt minus 2 power w by t. This is different. Surface tension mt minus 2. So finally, pressure and stress, they have similar dimensional formula. Specific gravity. What is specific gravity? Specific gravity is nothing but ratio between amount of substance, ratio between density of substance, density of water. So here, density of substance, we have density formula, mass by volume. So after placing that one, the density is ml power minus 3. The units are kg per meter cube. So here, this is about the substance density, this is about the water density. So here, specific gravity is a scalar quantity. It is defined as a ratio of density of substance to density of water at a reference temperature. So here, these are both are related to the densities. So this is a dimensionless. Moreover, it is a scalar quantity. So specific gravity is a scalar quantity and dimensionless. This type of the question will definitely, they will test you in examinations. So you have to focus on this type of the questions. Next, centripetal force. What is centripetal force? Centripetal force, that is the force which working toward the center. Force which working towards, see, this is center point. Force which working towards a center, that is called as centripetal force. Force which acting away from the center, that is called centrifugal force. So here, centripetal force formula, F equal to mv square by r. We can also consider in terms of omega, V equal to r omega, so that m r square omega square by r, it is m r omega square. So this is about centripetal force formula. Okay, coming to next question, which of the following pairs of have same physical quantities? See here, impulse, force into change of time. Okay, force into change of time, that is force mlt minus 2 times, so that is mlt minus 1. Impulse is Newton second. Coming to linear momentum, mass and velocity, that is mlt minus 1, which is about kg meter per second. So these two are same dimensions. Not only that one, work and torque. So impulse and momentum, work and torque, both are having same pair dimensions. Joule, it is equal to how many ergs? Joule is a unit for the energy. It is a unit for energy. So here 1 joule, it is equal to how many x? That is equal to 10 to the power of 7. So yes, sorry, 1 joule equal to 1 unit of the energy is joule. 1 joule is about 10 to the power of 7x. 1 joule, that is about energy units are ml square t minus 2. ml square t minus 2. Joule is the SI method and erg is CGS measurement. So that 1 joule, it is equal to 10 to the power of 10 to the power of 7 erg. You can see 1 joule equal to 1 kg and 1 meter square 1 second. After simplification you will get 10 to the power of 7 x. Coming to next one, dimension formula of the universal gravitation constant. Just now we discussed here. This is the answer. But here gravitation, I am going to discuss about the gravitational force. First of all, we have 4 fundamental forces. One is called strong nuclear force. Next one is electromagnetic force, weak nuclear force, and gravitation force. You can see the strongest force is strong nuclear force, weakest force is gravitation force, and next one strong nuclear force after electromagnetic force after weak nuclear force after gravitation force. So that gravitation force is known as weakest force. It is known as weakest force. It is central force. Weakest force, central force. It is conservative force which depends on initial and final positions. It is about it follows inverse square law. It is applicable to point size masses. So this is about gravitation force. Here F, as you know very well, F is proportional to m1 m2 by r square. After removing this proportionality, then F equal to m1 m2 by r square. When you multiply with 6.6 into 10 to the power of minus 11 Newton meter square per kg square, and this value is given by Cavendish. Who is that? Cavendish. Coming to next one, which of the following is not a unit of the distance? See, light year, parsec, astronomical unit, they are the unit distance, therefore units of the distance. But bar is not unit of the distance. It is about the area of the nucleus or area of the cross section of the atom or nuclear area cross section. See, astronomical unit is what? 1.49 10 to the power of 11 meters. Light year 9.46 10 to the power of 15 meters. Parsec 3.08 10 to the power of 16 meter. These are the units for astronomical. Sun to earth, light year, distance traveled by the light ray. This is parsec. 3.2 into light year is nothing but parsec. These are in meters. 1.46 10 to the power of 11, 9.46 10 to the power of 15, 3.08 10 to the power of 16. These are the units of the astronomical unit, light year and parsec in terms of values in terms of this concept. But here the answer is Born is not a unit. Born is a unit of nuclear cross section, which is equal to unit of nuclear cross section area, which is equal to 10 to the power of minus 28 meter square. Coming to next one, which of the following will have the negative mass dimension? As you know very well, gravitational potential here no m, and acceleration no m, only we have gravitation constant which is m power minus 1. So that your answer is automatically this one only. Coming to next one, the dimension formula coefficient of viscosity. You can go for coefficient of viscosity. So here just I am taking this simple one. This is Stokes law, F equal to 6 pi eta r v. So after replacing things you will get eta. Eta is nothing but coefficient of viscosity, that is F by 6 pi RV. After putting this value F equal to mlt minus 2 by R is nothing but distance, V is nothing but velocity. Am I right? Let's go for mlt minus 2. mlt minus 2 mlt minus 2 R is length, velocity length by time. So m L minus 1 you can check here, then t minus 3. So this is okay, something is missing. Okay, sorry, here also is this is plus minus 2 plus 1, so m L minus 1 t. So this is the dimension formula for the coefficient of viscosity. Viscosity is nothing but sticky nature of a fluid. Fluid is nothing but liquid and gases. Identify the unit of the K. So here K equal to, it is option is wrong, but I will explain here to you. K equal to ET by Q. E equal to what? Energy. Energy is what? Energy is nothing but m L square T minus 2 into T by Q is nothing but charge, which is nothing but AT. So after simplification you will get m L square T minus 2 A power minus m means what? Kg. L square means what? Meter square. T minus 2 means T minus 2. Sorry, T minus 2. It's not T minus 2. Okay. Here is T minus 2 only. T minus means minus second. Then area minus 1 ampere. So your answer is kg meter square second power minus 2 ampere power minus 1. So here minus 2, here minus 1. So that is answer correct. You can recheck once again, no problem. Okay, coming to strain as dimension. As we know very well, strain do not have dimensions. So strain is nothing but change in original length to change of the length. It is a ratio between original length to change of the length. That is about the dimension formula. So that is we will consider it is a ratio between original length, change of length to original length. So that it is no dimensions. Coming to fourth in one fundamental quantity. Okay, how many fundamental quantities? We have 7 fundamental quantities. That is already we discussed 7. Length of mass time, that is current, luminous intensity, temperature, like that we have 7 base units. They are known as fundamental. What is the dimension analysis for the linear moment? The linear moment just we discussed, that is P equal to mv. M as to V is nothing but L by T. So that is ml T minus 1. So this is about the dimensional unit for the momentum. And pressure P equal to F by A, which is nothing but ml T minus, that is we discussed. So that is ml T minus 1. So this is about the unit for the pressure. Pressure is nothing but just like stress. And dimension formula, work is nothing but work by, sorry, power is nothing but work by 10. Work is nothing but ml square T minus 2 by T. After simplification you will get ml square T minus 3. This is about the unit of the power. Power is nothing but watt. The dimension formula for the power is ml square T minus 3 and its unit is watt. Then coming to significant number, and this is simple one, so I don't want to waste time, going quickly, sorry. So that is about 340. This is about the significant figure. So yeah, the answer is 3. Coming to which instrument is used to measure internal diameter. Internal diameter will be measured by using a vernier calipers. This is about the main scale. This is about the vernier scale, and 0.1 millimeter is the least count for the vernier calipers. Formula is MSR plus VSR into LC. Coming to dimension analysis for significant figure for 0.03250. So here this is non-significant, and this is about the significant. So your answer is 4. Coming to rounding of number to the 4 digits. 4 is 1, 2, 3, 4. So here 67.8. Question is asking for only 4 significant figures rounding up. Coming to next one, just we discuss here. It is asking about the dimension formula for the power. This is repeated. This is well known. ml square t minus 3. Coming to the significant number, as you know very well, non-significant, 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 significant, 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 significant. So that your answer is 4. Leading zeros are not significant. Zeros between non-zeros are significant. You can see. And trailing zeros are significant after decimal. So non, 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 significant, 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 significant. So that next, 80 miles per hour in what? In meter per second. See, simple one. 1 mile equal to 1609. Means 1609 meters are equal to 1 mile. So now we have to convert 80 miles. 1 mile equal to 1609. And per hour is what? Hour 360 seconds. 1 hour equal to 60 minutes, 60 seconds. So after putting the values, you will get 24.78 meter per second. Dimension formula of density. Density is nothing but mass by volume. That is about ml m into L t to the power of minus 3. This is our dimension formula for the density. And coming to last one, questions will ask like resistance, resistivity. You have to focus. This is one more question I already given here, but you try your do your this explanation. You do yourself. This is the dimension formula for the resistivity. This is the dimension formula for the resistance. ml square t power minus 3 a power minus 2. This is dimension formula for the resistance, and this is the dimension formula for resistivity. Similarly, V equal to W by Q. This is about the potential. ml square t minus 2 Q is nothing but 80. So that is m as it is L square t minus 3 a power minus 1. This is about the potential or voltage. Work done to bring a charge. And significers. These are rules. You can recheck the rules. And this is about the round to the numbers 4.352. So thank you.